Welcome to This Explainer. Today, we're going to explore something you use literally every single day, probably without ever giving it a second thought. We are going to completely pull back the curtain and demystify the massive, completely invisible infrastructure that powers modern wireless networks. I'm talking about the complex hidden web of enterprise Wi-Fi.
So think about this for a second. How is it possible that you can be streaming a high-def video or on an important VoIP call on your phone while physically walking from one side of a massive corporate campus or university to the other? If you tried doing that while walking down your residential street, your phone wouldn't just magically hop from your Wi-Fi to your neighbor's Wi-Fi, right? No way! The connection would drop instantly. So what exactly is happening behind the scenes in an enterprise setting that allows hundreds or even thousands of access points to act like one giant continuous network?
Well, to understand the brilliant solution, we first need to understand the problem. And it all starts with what we call the lone wolf router problem. You see, in a small office or home network, you have what's known as an autonomous access point. This is a self-contained unit. It acts almost exactly like that standalone router you've got sitting in your living room right now. It's equipped with both the wired and wireless hardware, and it bridges wireless data from the air straight into a normal wired network right there on the spot. It is completely autonomous. And hey, bless its heart, this little box is working incredibly hard, doing absolutely everything all by itself.
But imagine the sheer nightmare this creates at an enterprise scale. What if you have 1,000 of these lone wolves? Because every single autonomous AP handles its own data routing and management locally, network engineers actually have to manually configure every single unit. Want to add a new virtual LAN? Well, prepare to touch every switch and every AP in the entire building. Plus, client roaming is severely restricted. You're usually boxed into a single Layer 2 VLAN domain. And because you absolutely have to create redundant links to prevent network failure, you're forced to run these incredibly complex spanning tree protocol setups just to prevent your data from looping and crashing the whole system. It's an agonizing, totally unscalable mess.
Which brings us to a really fascinating question. If we already have all this autonomous hardware bolted into the ceilings of our buildings, what if we didn't rip it all out? What if there was a way to just, control all of these independent lone wolves from one central location?
The genius trick here, and we see this with cloud-based AP architectures like Cisco Meraki, is essentially splitting the network's brain right in half. We take the management control, the control plane, and we push it entirely out of the physical building and up into the internet cloud. This means an engineer can just sit at a central dashboard and push out configurations, automatically tweak RF channels, and gather data on interference, all from one spot. But, and this is crucial, we keep the actual data routing local. The data plane stays right there on the access point, so your Netflix stream doesn't have to take some massive laggy detour to the cloud and back. The AP remains autonomous for routing data, but its management is beautifully centralized.
Okay, so that solves the management headache, but it still leaves a ton of heavy lifting on the AP itself. It's still making lots of localized decisions. So let's push the boundary even further. What if we completely stripped the intelligence out of the access point? What if we literally removed its brain entirely?
This brings us to a heavy industry concept that is the absolute backbone of massive enterprise networks today. It's called split MAC architecture. Basically, normal media access control or MAC operations are pulled entirely apart into two distinct locations. We take all the heavy management functions and shove them over to a central controller, leaving only the real-time radio frequency or RF functions inside the access point.
Let's look at this as the ultimate brain versus muscle analogy, right? On one side, we have the brain, the wireless LAN controller, or WLC. This centralized brain handles all the complex logic. It authenticates clients, manages security policies, handles that magical seamless roaming across the campus we talked about, and it even dynamically adjusts the transmit power of the entire network to heal coverage dead zones. On the other side, we have the muscle, the lightweight access point. We actually call it lightweight because its code and local intelligence are totally stripped down. It relies completely on the WLC. Its single job is to just efficiently blast out real-time RF transmissions and perform hardware-level encryption on a per-packet basis. All muscle, no brain.
But wait a second, if we've totally separated the brain from the muscle, and they might be located in completely different physical buildings, on different IP subnets, sometimes literally miles apart, how on earth do they actually communicate securely in real time?
Well, they do it by digging a virtual tunnel right through the network. They use a protocol called CAPWAP, which stands for Control and Provisioning of Wireless Access Points. Here's how it works.
First, they have to securely prove who they are using pre-installed X.509 digital certificates, so absolutely no rogue APs are allowed in. Next, they dig a dedicated control tunnel using UDP port 5246 to carry all that management traffic from the brain. Finally, they open up a data tunnel using UDP 5247. All of your client data, your high-def video stream, your emails is securely encapsulated inside this tunnel and routed over Layer 3 IP networks straight to the controller.
So, if every single lightweight AP on a sprawling campus is tunneling all of its data back to one central brain, where exactly do we hide this massive piece of hardware in the network topology?
As you might guess, the physical reality is pretty intense. Imagine thousands of CAPWAP data tunnels terminating in one single room. You need incredibly dense, high-capacity cabling and ultra-robust core switches at the dead center of the network just to handle the sheer, massive volume of data being untunneled and routed out to the internet or local servers.
But the truly brilliant part is that the brain actually scales to fit whatever your reality is. Running a gigantic university, a unified core controller handles up to 6,000 APs from the center of your network. Insane, right? Or maybe you want a virtual cloud deployment hiding in your data center. That'll support up to 3,000 APs. For smaller setups, you can just embed the controller right into a local switch for a couple hundred APs. And for tiny, distributed branch offices, Mobility Express actually hides the brain software right inside one of the APs itself. It's super flexible.
Now I've got one final micro mystery for you. We know these lightweight APs act as the muscle to provide us with sweet Wi-Fi. But what if we need the muscle to do a completely different job? What if we needed to act as a security guard instead?
Because the brain is completely in charge of the show, it can instantly change the muscle's job on the fly. It's wild. Aside from local mode for normal Wi-Fi, it can pop into monitor mode to act purely as an intrusion sensor. Tunnel drops? No problem. Flex Connect keeps the branch office online locally. It can become a sniffer to capture raw traffic for engineers, or a rogue detector to literally hunt down unauthorized hackers trying to spoof the network. It can even fire a dedicated bridge laser link between distant buildings, or use C-Connect to become a dedicated spectrum analyzer looking for microwave or Bluetooth interference. It is an absolute Swiss Army knife of networking superpowers.
When you really step back and look at it, split MAC architecture represents the perfect harmony of brain and muscle. By separating the heavy logic and decision-making from the physical radio transmitters, network engineers have beautifully solved the ultimate scaling problem. You can deploy thousands of APs across dozens of buildings, and because they're all just extensions of one centralized brain, they act as a single, perfectly orchestrated network.
So what's the big takeaway here? Well, the next time you're walking through an airport, a hospital, or a corporate office, watching a video without a single stutter, I want you to look up at the ceiling. Seriously. Think about that invisible web of CAPWAP tunnels passing through the walls. Think about that centralized brain making microsecond decisions to seamlessly hand your phone from one lightweight muscle to the next. The invisible engineering all around us is absolutely fascinating once you actually know what to look for. Keep learning, keep wondering, and keep asking how things work.